Hello everyone and welcome back to MUSM's Ashok Vidyalaya and Junior College online chemistry lecture. This is Mrs. Rohini Hulle, your chemistry teacher. Now let us get started. Today we are going to talk about aldehydes, ketones and carboxylic acid. Now we'll take different types of reactions. These are the nucleophilic. These are the chemical reactions of aldehydes and ketones with nucleophile. In that we'll see haloform reaction. See, acetaldehyde is the only aldehyde which gives haloform reaction. Means acetaldehyde is the only aldehyde which gives haloform reaction. Means only acetaldehyde gives haloform reaction. All methyl ketones means this methyl and this ketone group, and all alcohol containing CH3 means CHOH group gives haloform reaction. Means for students, only acetaldehyde and methyl ketones give haloform reaction. Now next point, when an alcohol or a methyl ketone is warmed with iodine and sodium hydroxide, a yellow precipitate of iodoform is obtained. Means when an alcohol or methyl ketone is warmed with iodine and sodium hydroxide, a yellow precipitate of iodoform is formed. Means in this reaction, an alcohol or methyl ketone warmed with iodine and sodium hydroxide, then yellow precipitate of iodoform is obtained. This is characteristic formation of haloform reaction. Now next, thus methyl ketones are characterized by iodoform test. Means methyl ketones are characterized for this iodoform test. Okay. Now next point, here the reagent sodium iodide is produced in situ. Means which reagent used in this reaction, that is sodium hypoiodide, is produced in situ. Situ means in the reaction mixture. Now next, during the reaction, sodium salt of carboxylic acid is formed, which contains one carbon atom less than the substrate. We will see in next slide, that is reaction. In that reaction you will clear. Okay. The methyl group is converted into haloform. Now next slide, we will move to next slide. See, in this reaction, this is haloform reaction. This acetone is oxidized with by sodium hypoiodide. This is sodium hypoiodide, NaOI, to give sodium salt of acetic acid. This is sodium salt, means Na is Na positive and O negative, is known as sodium salt of acetate. CH3COO means acetate, and this is sodium, so sodium acetate. And iodoform, yellow precipitate of iodoform is yellow iodoform is precipitate. This is iodoform. CH3I3 means iodoform, and NaOH is a byproduct. This is haloform reaction. Student, haloform means this is iodoform, so the name is haloform reaction, and the reagent used is NaOI, means sodium hypoiodide. Okay. Now next slide, we'll move to next slide. Aldol condensation. This reaction is very important for your examination. Okay, now aldol reaction. See first, what is the aldol reaction? It is the definition of aldol reaction. See what is the aldol reaction. Aldehydes containing at least one alpha hydrogen, means this aldehyde containing one alpha hydrogen. What is meant by alpha hydrogen? Alpha hydrogen is that which is attached to that carbon atom, and that carbon atom, and this carbon atom must be attached to functional group. So see, in this aldehyde, this is aldehyde containing at least one alpha hydrogen atom, means this is CHO group, aldehyde group, and this is alpha carbon atom, and hydrogen is attached to this carbon atom. So this is alpha carbon atom. Undergo a reaction in presence of dilute alkali like NaOH, KOH, and Na2CO3. These are the dilute alkalis. See, in this reaction, these are dilute alkalis. As a catalyst, this dilute alkali reacts as a catalyst, means they do not take part in the reaction, but the rate of reaction increases, is known as a catalyst. Okay, as a catalyst to form beta hydroxyaldehyde. This is beta hydroxyaldehyde. See, this is alpha carbon atom, this is CHO attached to this carbon atom is alpha carbon atom, and this is beta carbon atom, gamma, etc. Okay, and to form aldol, that is beta hydroxyaldehyde. This is known as beta hydroxyaldehyde. Formation of aldol is an addition reaction. This is an addition reaction. Then this aldol formed when aldehyde reacts with dilute NaOH to form aldol. Aldol means beta hydroxyaldehyde. In this reaction form beta hydroxyaldehyde. This aldol formed aldehyde having alpha hydrogen undergoes subsequent elimination of water. This elimination of water is formed by warming. There is warm. In this reaction, there is warming of water, and the elimination of water molecule give rise alpha beta unsaturated aldehyde. Okay, this is alpha beta unsaturated aldehyde. This is alpha and beta. Unsaturated means having double bond to form alpha beta unsaturated aldehyde. This reaction, aldol condensation, is very important for your examination. Okay, now next we'll move to next slide. Now this is example. I think one slide is missing here. Okay, next slide. See, this is example. When this ethanol means CH3CHO, two molecules of ethanol reacts with dilute NaOH to form 3-hydroxybutanol and aldol. This is an aldol formation. Okay, means aldehydes. This is aldehyde containing at least one alpha hydrogen atom. This is alpha hydrogen atom. Undergoes a reaction in presence of alkali. This is alkali as a catalyst to form beta hydroxyaldehyde, means in this aldol and aldol there is formation of an aldol. See, this is beta hydroxy, alpha carbon atom and beta carbon atom, and this is beta hydroxy, and there is removal of water molecule to form bute 2-enal. This is unsaturated alpha beta aldehyde. This is example of an aldol condensation. We must always take 2 molecules of aldehyde in aldol condensation. Okay. Now, the overall reaction is called aldol condensation, and this overall reaction is known as aldol condensation. It is a nucleophilic addition elimination reaction. This is nucleophilic addition and elimination. First addition reaction takes place and then elimination reaction takes place. So it is nucleophilic addition elimination reaction. See, in ketones containing at least 2 alpha hydrogen atom also undergo aldol condensation reaction and give an alpha beta unsaturated ketone. This is propanol. Propanol means ketone. This is ketone group. Propanol on reaction with BaOH twice to give 4-hydroxy 4-methyl pentane 2-on means alpha beta unsaturated ketone. See, first there is formation of ketone, okay, and then on elimination of water molecule to form 4-methyl 3 in 2-1 means this is 4-methyl 1 2 3 4. This carbon atom CH3 is attached to this carbon atom, 4th carbon atom, that is beta carbon atom, and 3 in, this is 3 in 1 2 3. 3 in means having double bond. This is unsaturated ketone, okay, and 2 1 2 ONE1 means ketone group, okay. This is aldol condensation reaction. Now next slide. This is cross aldol condensation. This is also very important for your examination. In exam, explain cross aldol condensation with suitable example. Like this question, they may be asked, okay. Cross aldol condensation. First, see, cross aldol condensation refers to the aldol condensation that takes place in between 2 different aldehydes and ketones. Means cross aldol condensation takes place in between 2 different aldehydes or ketones. See, in this reaction there are 2 different aldehydes, that is ethanol and propanol, okay. In both aldehyde and ketone contain 2 alpha hydrogen atom. Each then a mixture of 4 product is formed. Means in both aldehyde there contain 2 alpha hydrogen atom. Means in aldehyde or ketone it must be contain 2 alpha hydrogen atom, and then a mixture of 4 product is formed. There is formation of self condensation and cross condensation. See, in this reaction a mixture of ethanol and propanol. See, in this mixture of, this is ethanol and this is propanol. On reaction with dilute NaOH, this is a base and used as a catalyst. Followed by heating gives a mixture of 4 products. See, when heated, there is formation of 4 products. 1 crotonaldehyde, second 2-methyl pent 2-enal, third one, this one 2-methyl but 2-enal and pent 2-enal. 2 products for self condensation. These 2 products are for self condensation, crotonaldehyde and 2-methyl pent 2-enal, and 2 for cross condensation product. These 2 are for cross condensation product, 2-methyl but 2-enal and pent 2-enal. These are 4 products formed in the cross aldol condensation. See, self condensation and cross condensation. Okay. Now we'll move to next slide. Now next is Cannies-Haro's reaction. See, it is very important reaction. This reaction is given by only aldehydes having no alpha hydrogen atom. Students, you must remember here in Cannies-Haro's reaction there is no alpha hydrogen atom. But in previous slide we have seen that is in aldol condensation there must be alpha hydrogen atom. But in Cannies-Haro's reaction there is no alpha hydrogen atom. Okay. Aldehydes undergo self-oxidation and reduction reaction on heating with concentrated alkali. Means aldehyde undergo self-oxidation reduction. This is the self-oxidation reduction is the characteristics of an aldehyde. Without a hydrogen is the self-oxidation reduction, and they undergo in presence of this alkali. This is known as self-oxidation reduction reaction. Means Cannies-Haro's reduction is also known as self-oxidation reduction reaction. Okay. This is an example of disproportional reaction. Now see, in this reaction, in Cannies-Haro's reaction, this is Cannies-Haro's reaction, one molecule of an aldehyde, one molecule of aldehyde is reduced to alcohol. There are two molecules of aldehyde, two molecules of formaldehyde. HCHO is known as formaldehyde. One molecule of aldehyde is reduced to this alcohol, that is methanol, and one molecule is oxidized to, second molecule is oxidized to carboxylic acid salt. This is sodium formate. Means there is formation of oxidation and also reduction. So it is known as self-oxidation reduction reaction. One aldehyde is reduced to methanol and one aldehyde is oxidized to carboxylic salt, CHOO means carboxylic salt. Okay. Now we will see second example of this Cannies-Haro's reaction. See, benzaldehyde. This is another example of Cannies-Haro's reaction. This is benzaldehyde. Two molecules of benzaldehyde when reacts with KOH to form one molecule of benzaldehyde is reduced to phenylmethanol. Phenylmethanol is also known as benzyl alcohol. See, CH2OH. When CH2OH attached to this benzene ring is known as benzyl alcohol. CH2OH means this reduced to phenylmethanol, and one is oxidized to potassium benzoate. Why here potassium? Because we use KOH as a base. Okay. This is another example of Cannies-Haro's reaction. Now next we will see next reaction, that is cross Cannies-Haro's reaction. This is cross Cannies-Haro's reaction. See students, when a mixture of formaldehyde, this is mixture of formaldehyde and non-profit, mixture of formaldehyde and non-inosable aldehyde. Inosable aldehyde means aldehyde with no alpha hydrogen is treated with strong base. This is strong base means this is aldehyde with no alpha hydrogen atom is treated with strong base NaOH. Formaldehyde is oxidized to this formic acid, and another aldehyde is reduced to this alcohol. To form one aldehyde is reduced to this formic acid, and one aldehyde is oxidized to phenyl methanol. This is known as cross Cannizzaro reaction. Means there are two different aldehydes, formaldehyde and benzaldehyde, in presence of concentrated NaOH as used as a base. It is a base used as a, there is a, sorry, concentrated NaOH is a base. Then one formaldehyde is oxidized to formic acid and benzaldehyde is reduced to alcohol, that is phenyl methanol. Okay, these all reactions are very important for your examination. With this we reach to end of our today's lecture. Go through it, students. This has been Mrs. Rohini Hulle. See you in your next chemistry lecture. Bye for now. Thank you so much.